So we're going to now do modeling linear growth and decay. I will split this up into a series of videos, and we'll start off first with definitions of modeling linear growth and decay. So linear growth and decay, so increasing and decreasing, this is your increasing, this is your decreasing, and decay is commonly found around the world. They occur when quantity increases or decreases by the same amount at regular intervals. Everyday examples include things like the paying of simple interest or the depreciation of the value of a new car by a constant amount each year. So obviously the depreciation means it's going down in value by a constant amount every year. A recurrence model for linear growth and decay. So because we're doing recurrence relations, we have to model this via recurrence relations. So the recurrence relations here I've got is P of O is 20, and then I've got here P of n plus 1 equals P of n plus 2. So that means this one's increasing. This one here is increasing. So that's growth. And then you've got QO equals 20 as your initial, and you've got Q of n plus 1 equals Q of n minus 2. There's your decay. That one there is decreasing. So you can see that the difference between the two. One's a plus and one's a minus. That tells us what's increasing and what's decreasing. So both have rules that generate sequences with linear patterns. These are straight lines, and you'll see that in the next slide anyway. Now, the first generates a sequence whose successive terms have a linear pattern of growth, and the second one is a linear pattern of decay. So let's have a look at the table. So there's our first recurrence relation there. We're adding 2 every time, so 20, 22, 24, and you can see our initial starting point was here. See, 0 is at 20, then 1 goes to 22, then 2 to 24, so on and so forth, and you can see that straight line increasing that way. That's leaning to the right, so it's a positive gradient. Then you've got your second recurrence relation they gave us there, Q of O equals 20, and we're going down by 2 each time, so we're starting at 20, 0, see there, there's your X, which is your n number of iterations, there's your X and there's your Y as well. So 0 is at 20, and we're going down by 2 each time, so the next one's at 18, 2 is at 16, 3 is at 14, and so on and so forth. And you can see that you've got that straight line going that way, and that's leaning to the left, and that's a negative gradient. So in general terms and as a general rule, what would we need to do is you guys have to please make sure you've got these stuff in your notes. So for linear growth, we'll be using V of n plus 1 equals Vn plus d. That's your constant, and V of n plus 1 Vn equals Vn minus d for linear decay. Those are the two important ones, and I'll split up the video for the next part.